Alrighty. In today's lesson, we're going to be looking at 11.3, which is determinants and Cramer's rule. All right, so let's get into the notes of it, and then we'll do a few examples. So basically, the determinant is basically if A is equal to the matrix. They use like a A11, A12, and I totally get that, but I find it easier to go A, B, C, D. Then, so if the matrix A is in basically a 2 by 2, then the determinant is denoted by, looks like absolute value of A, as not an absolute value of A. That's just how it's denoted. The equation is just AD minus BC. Basically, you take this diagonal minus this diagonal. So you can use the A11 times A22 minus A12 times A21. Totally okay with that. I just find it that this is a little bit easier to understand. All right. There is also minors and cofactors that we can use to find. And what these do, it basically makes finding the determinant of a 3 by 3 or greater a lot easier. So that's why we talk about minors and the cofactors. To find the determinant can actually tell us it can tell us quite a little bit about it, but it kind of goes into vectors when you eventually learn that. I don't know if we get into vectors or not in this course, but it tells you basically the area of a two-dimensional figure being moved. It could tell you the direction it's being moved, things like that. But for now, it's just learning how to use it. All right, so minors and cofactors. Again, minors will actually help us use to find determinants of larger than 2 by 2, because this is super easy to find determinants of 2 by 2s. Gets a little bit more complicated for anything larger than that. So a minor of an element, let's call it Aij, is the determinant of A by deleting the ith row and jth column. Basically meaning if I have the A11, A12, A13, A21, A22, A23, A31, A32, and A33, and I wanted to find the minor of A12, then what I would do is I would delete row 1, column 2, and then now find the determinant of A21 times A33 minus A23 times A31. So basically, and that's how you'd find the minor. So, and that would help us later on how to find the determinant of a 3 by 3, but we'll get into that a little bit later. To find a cofactor, one extra step. So a cofactor of the element Aij is going to be -1 times I plus j times the minor. So whatever you end up getting on the minor, you would then multiply it by this. And really what it comes to be is if I plus j is even, it equals the minor. And if I plus j is odd, it is the opposite of the minor. Meaning if the minor ends up being 2, then the cofactor, if I plus j is odd, is -2. All right, so to use the minors and cofactors, what we do to find the determinant of a n by n matrix, be specific there, you basically would take what I just did. So you would take a 3 by 3, so A11, A12, A13, A21, A22, A23, A31, A32, and A33. And what I can do is you just pick an element to find the determinant of. So typically you would want to look for things that have like lots of zeros, but obviously we don't have any numbers here. So I'm going to choose this row right here. So let's get a different color. I'll choose this row right here. So what that means is I'm going to choose A11, and since it's even, it'll stay positive, and then I'm going to delete that row and that column. So therefore I would just find the determinant of A22, A23, A32, A33. And then I would go A21. And since it's odd, it becomes its negative. And then now I delete that row, delete that column, and now it is A12, A13, A32, A32, and I would find that determinant. Then I would go to A31, and because 3 plus 1 is even, it's going to be a positive. And then I would delete that column, delete that row, and so then I would find the determinant of A12, A13, and then A22 and A23. So then that right there, whatever that total is, would end up being my determinant. This is why you want to look for a row or column that has a bunch of zeros so that you can delete some of the answers, because 0 times whatever this is going to be 0. Gives you less work to do. All right, so we do have some properties of determinants. And sometimes this can make doing the math a little bit easier as well. Always looking for those tricks and shortcuts. One, you can actually factor a like term out of a row. Meaning if I have a matrix 2, -1, 15, 5, I might notice that this row has a 5 in common and becomes 3, 1. And this right here would be my answer. So I could still do the 2 times 1. So for instance, this is 2 times 5, which is 10, minus 15 times -1, which is -15. So I get positive 25. And then if I factor that out, I can still get the same answer. That's 2 times 1 minus -3. So that gives me positive 5 times the 5 gives me 25. So you can see I can factor things out to make the number smaller and then reapply it later. The second property you have is you can interchange rows by a factor of -1. Meaning if I have this 2, -1, 15, 5, and I felt that it was a little bit easier to do the math on a different direction, I can factor out a -1, and now I have 15, 5, 2, -1. And again, you could see that you'll get the same answer. We know that this was 25, so let's redo this one. 15 times -1 is -15. 2 times 5 is 10, so that gives me -25. Apply the negative, and I get the positive 25 again. So again, another way, maybe that right there makes it a little bit easier to do the math. And then the last property is the determinant is unchanged by adding a multiplied row. Right? So that means that if I have something like this, I'll take 3, -2, 1, -1. And let's say I want to multiply row 2 by -3 and add it to row 1 to get a new row 1. I would then get 0, 1, 1, -1. These would still be the same answer. So this is -3 minus -2. That produces a positive, so it gives me -1. 0 times -1 is 0, minus 1 times 1, which is 1, which gives me -1. So again, applying a multiplied row and adding it to another will not change the answer to the determinant. So those are 3 different properties for determinants, and that's pretty much the first half of this lesson. The second half of this lesson is using Cramer's rule to solve. So solving using Cramer's rule. And this just gives us a shortcut of answering the questions that we did in 11.2, but using determinants. So if we have a 2-variable equation, let's call it ax plus by equals e, and cx plus dy equals f. Then using Cramer's rule, x, if I eliminate this guy, will be the determinant. So that would be the E, D, F, D. I bet E, B, F, D. Divided by this determinant without what the solution is. So that would give me A, B, C, D. So then what I would do to work this out is this would just be ED minus FB over AD minus BC. So using that stuff, I can just plug this in and I'll instantly get the answer. And also using Cramer's rule, Y, again, eliminating B and D, I would get A, E, C, F. Make sure I wrote that right. Yep, okay. And then over the determinant without the solution, so that'd be A, B, C, D again, which basically just comes out as AF minus EC over AD minus BC. And then I would instantly have my answer. So using Cramer's rule, I can just do a little multiplication and subtraction, and I'm done, and I don't have to worry about using the matrix C multiplication. Now, we can also use Cramer's rule to find an infinite amount of linear equations. So using Cramer's rule for n linear equations, it's a little bit more work, but can still be the same. So if we just call them all x's, we can say, well, x1 will be whatever the determinant of x1 is divided by d. And then x2 would be whatever the determinant of x2 is divided by d. And so on and so on. So then xn would equal the determinant of dxn over d. And so you can find infinitely many of them using Cramer's rule. So that's pretty much everything that was in the lesson. So let's go over a couple or a few of the homework questions so that you have everything you need to be successful. All right, here we go. So let's look at number 4 first. Number 4 says evaluate each of the following determinants. And you're given 34, -2, 17, -1. So again, all you have to do is take this diagonal and then multiply these diagonals and then subtract it from these diagonals. So this would be 34 times -1 minus -2 times 17. Right? Then you just do the work. This is -34. That would make it a positive, and then 2 times 17 is positive 34. So negative 34 plus 34 would give you 0. That's literally all you have to do. So let's do another one. Let's look at number 8. Number 8 is AC to AD, BC, DB. Right? They're going to try and make this more complicated than it needs to be, but it's the same process. I'm still going to take this diagonal. That's going to be AC DB minus this diagonal. So that'd be 2ADBC. I don't know how much they want to simplify. Actually, if you look at it, ACBD, it's all the same thing. And since I have one of these and negative 2 of these, I really have a negative ABCD. So because multiplication is commutative, I can rearrange this as one set. And I didn't even see that until just now. So therefore, that would be your answer. All right, so that's probably about as complicated as it will get. Let's look at another one to make sure you have plenty of examples. Let's look at number 11. So this is negative 2, 9, 5, negative 3. So this would be, again, this diagonal here. So negative 2 times negative 3 minus 9 times 5. So that'd be 6 minus 45, which gives me negative 39. And then that's it. Again, doesn't get more complicated than that when it comes to 2 by 2 matrices. All right, let's look at some different questions. Let's look at the set of 22 through 30. And you are asked, or you are told that A is equal to 2, negative 1, 5, 0, 1, 3, 1, 0, negative 2. Let's look at number 22. Number 22, you're asked to find the minor of A12. So to find the minor of A12, that means I'm going to delete row 1 and column 2. So that means I'm just going to find the determinant of what's left. So in this case, that's 0 times negative 2 minus 3 times 1. So that's going to give me 0 minus 3, which is negative 3. So for 22, the minor of A12 would just be negative 3, and that's all you would do. All right, I want to use this again, so let me erase that part. Let's look at number 26. Number 26 is asking for the cofactor of A32. All right, so this starts off by if I take I plus j, so this is my I, this is my j, so this is going to be some pre-work. Let's do it right here. So I plus j would equal 3 plus 2, which is 5. If it is odd, then it's going to be a negative in front of the minor. And if it is even, then it's going to be the answer to the minor. So since it's odd, I have a negative, and then I'm going to do the same thing. I'm going to delete row 3, column 2. So this now becomes 2, 0, 5, 3. Apply the negative later. So this is going to be 2 times 3 minus 5 times 0. It comes out to 6 minus 0, which is 6, which gives me negative 6. So that's how you find the minor and cofactor. Cofactor is literally the same as the minor. It just has that one little extra step. Is it going to be a negative or a positive? Or is it going to change the sign or be the same as the minor? All righty. Look at a couple more, and then I think that would be enough examples for y'all. So let's look at number 39. Number 39 asks you to evaluate each of the following determinants. In each case, minimize the required number of computations by carefully choosing a row or column to expand along, and then use the properties of determinants to simplify the process. So on number 39, you were given 2, 0, 1, negative 5, 1, 0, and 3, negative 1, 1. Again, you can go with any row or any column. I see that I have 2 zeros. But then I also see I have ones. So what I'm actually going to do is zeros are definitely the easiest, and then one will just be the second easiest. So I'm going to use the third column. You could probably get away with the first row even, or potentially even the second row, but definitely use something that has a zero in it to eliminate it. So what we're going to do is exactly what we did. Oh, we hadn't done it yet, but what we did on find a determinant of a 3 by 3. So I'm going to start off by taking the 1. Now this is the spot of A3, 1. So that's a 4, so that's even. So the 1 will stay the same. So this is the A3, 1 spot. And so that means I'll delete this row and delete this column. So then I'm left with, so again, I would delete this row and this column, and then I'm left with -5, 1, 3, -1. All right, so again, I need those numbers. I completely lost the 1. All right, so now I'm going to do this one. So this one's going to be 0, but this is again, this right here is going to be, all right, man, I got that mixed up. Same math, but this is row 1, column 3. This is going to be row 2, column 3. So that's a 5. That's odd. So that's going to be a negative. And then I would delete this row and this column. So then that would be 2, 0, 3, -1. Again, I need those numbers. All right, this one here is then going to be row 3, column 3. That's even. So it's going to be a positive. So then a +1. And then I'll delete that row and that column. So now I have 2, 0, -5, 1. Whatever this result is will be my answer. So we try to find things with zeros because that will get rid of that work. So I really just have this work, but since I chose 1, I don't have to do an extra multiplication problem. I just have to do -5. I don't know why I got 2 parentheses there. Hold on. I just got -5 times -1 minus 1 times 3 plus 2 times 1 minus 0 times -5. So this gives me 5 minus 3 plus 2. That would zero out. So then that's 5 minus 3, which is 2, 2 plus 2, which is 4. So the determinant of number 39 would be 4. It doesn't matter which row you would have chose. Any option you would have gave you would have gave you the same conclusion. The goal was just to see which one could have the least amount of work. All right, let's do another one to make sure you understand that concept. So let's look at number 40. 40, same process. This time I'm given 12, 3, 1, 1, 1, -1, and then 0, 2, 0. So on this one, I notice I have 2 zeros in this column. So I'm actually going to use this one. I'm going to go ahead and label this. This is A31, A32, and A33. This will make the process go a little bit quicker. So this is going to be 0 times whatever this element is. So in this case, I'm not going to do that work. I already know it's going to delete. The only thing I'm going to have to do is 2. But 3 plus 2, that's a odd. So that means it's going to make it a -2. Again, you can write it out if you want, but I know that the determinants with the 0, it's just going to zero out. So the only one I got to do is the one with the 2. So this gives me 12, 1, 1, -1. That's what it's trying to tell you to write it out with least amount of computations. Now I went ahead and wrote this out so you could see, but hopefully now you can see if it has a 0, I don't have to do it. So this now gives me -2 times 12 times -1 plus, oh, my bad, minus 1 times 1. This is -2. 12 times -1 is -12 minus 1. That gives me -2 times -13, which comes out to +26. So for number 40, the answer is just 26. And if you wanted to do any of the other options, like maybe you thought maybe this one would have been good or this one's good, that's fine. You would still get 26 as the outcome. All right, let's look at one more type of question. So let's look at number 48. So on the homework, you are asked to use Cramer's rule, but you are only obligated to know how to solve a 2-variable equation. You won't have to worry about a 3-variable equation showing up. So here we go. So this would be 2x minus 3y equals 8, and 8x plus 5y equals negative 2. All right, so if I want to know what x is, all I have to do is use the rule. Hold on, let me see if I can get a quicker way of doing this. All right. So I was going to say, well, you can just delete this and do this way here. However, for the x equation, it is a little more specific. So it's going back to our Cramer's rule, where x ends up equaling ED minus BF over AD minus BC. So I'll do a little labeling for you. This is your A, B, C, D, E, F. That's how it's labeled. So therefore, in this one, that's going to be 8 times 5 minus negative 3 times negative 2. Divided by 2 times 5 minus negative 3 times 8. There we go. So that's going to be 40. That's going to be a positive and a negative, so that's minus 6. And then this would be 10. And then that's going to be a positive 24. So then that gives me 34 over 34. So that gives me 1. Again, I'm real curious again. I just want to do it one more time in my head. So this would be 6 minus 40, which will give me negative 34. So that'd give me negative 1. So that's why it's very specific to do it in this form and not just go this way with it, because it will give you a negative answer, which will be incorrect. So definitely make sure you use the formula. I was just trying to find a quicker way for y'all to remember how to do these. All right, so now y. Y's equation was AF minus CE over AD minus BC. So this would be 2 times negative 2 minus 8 times 8. So A was 2, F was negative 2, C was 8, and then E is 8. I've already done this work, so I'm just going to write 34. It was the same formula for X. So now this gives me negative 4 minus 64 divided by 34. So that gives me negative 68 divided by 34, and that happens to be a negative 2. So this is what my answer would be. So instead of having to solve this by elimination, by graphing, by substitution, by matrices, I instantly have the answer using Cramer's rule by just simply plugging it into its formula. All right, let's do one more to make sure you have another example. So let's look at, what was that one? 48. So let's look at number 49. So this is 5x plus 7y equals 9. And then 2x plus 3y equals negative 7. So again, label it up. So A, B, C, D, E, F. So X again would equal, man, that one, I just cannot remember like I came with the Y. So this would be ED minus BF over AD minus BC. So this would be 9 times 3 minus 7 times negative 7 over 5 times 3 minus 7 times 2. So this would be 27 plus 49. And this would be 15 minus 14. So that would give me 1. Real quick, calculator. 27 plus 49 gives us 76. So for my x, the answer would be 76. All right, and then we'll do y. And again, that was AF minus CE over AD minus BC. Plug it in. So that's going to be 5 times -7 minus 2 times 9. And I already did the bottom, so I'm just going to write 1. So it gives me -35 minus 18. What's that? 45, -53. And so there's my answer. 76 and -53. All right, and that's pretty much all that you're required to be able to do in this lesson. So I'm going to end it there. As always, if you need more examples, keep reaching out. Other than that, I'll see you in the next video.